One of the, I think, insidious aspects of marine heat waves is, of course, the fact that they are out of sight and out of mind. They're occurring hundreds, if not thousands, of kilometers away from land in many cases, some cases much closer to land. And like all life in the ocean, it's mostly hidden from view. And the studies have shown that they are responsible for mass die-offs of ocean life. I coined a term, not one of the happier terms I coined in my book, biotic genocide. And that's basically what's happening. And we are doing it to them. Hello, and welcome to another edition of the Climate Emergency Forum. I'm Herb Simmons. I'm the author of A Climate Vocabulary of the Future. And today's session will be on one of the climate phenomena that I think unfortunately hasn't gotten enough attention. The term is a very simple one, but with very profound consequences, marine heat waves. And what we're calling today's event and discussion is really hot water horror, marine heat waves. And so our usual two experts, Dr. Peter Carter and Paul Beckwith, will be talking about this relatively newly discovered phenomena of marine heat waves that are increasingly becoming more and more prevalent throughout the oceans of the world. And we hope that if you like what you hear and see today, that you will like this video, that you will subscribe to our channel, that you will go to our website, theclimateemergencyforum.org, that you will press, most importantly, the donate button so that we can continue to do shows like this that are focused exclusively on the climate emergency, and that you leave your comments and questions. We all read them very carefully and respond where appropriate. So with that as an introduction, I'm really happy to introduce Dr. Peter Carter. Peter, as those of you who know, is a doctor, a retired doctor who started the Climate Emergency Institute. He's been an expert IPCC reviewer, and he's been a longtime writer and observer of the impact of every aspect of climate, particularly climate and health. So, Peter, the floor is yours.
Thank you, Herb, and thank you for mentioning, which is so true, that marine heat waves are not getting enough attention. That's pretty bad because when I reviewed, of course, for this session, it's pretty obvious that marine heat waves alone, but when you add marine heat waves to ocean acidification, ocean deoxygenation, sea surface temperature, we have an ocean planet catastrophe already. This is a huge, huge catastrophe, and we're well into it. It has to be because, 19% of all the heat from our greenhouse gas emissions, lower atmosphere, goes straight into the oceans. And as many people have pointed out, ocean planet, as several of the ocean scientists pointed out when things were really, really hotting up, let me say, with ocean heat, they pointed out that really we should be following ocean heat content in preference to global surface warming. Global warming is a lousy indicator for us to use, and ocean heat is way, way better. Now, there's no up and downs in it. It just accelerates every year. It's a record. So, marine heat waves, of course, they've shot up every time there's been an El Nino, shot up in the 1998 and 2015-16, and clearly in 2023. And every one of these huge spikes, these huge increases, was a new record in how high the spikes can go up with the El Nino and global warming. From about 2000, the marine heat waves have clearly been increasing at an accelerating rate, like so many of the other indicators. So sea surface temperature, there has been, I think, quite a bit of publicity on that. It is increasing at an accelerating rate, and it's a huge, huge increase above what was previously the normal. And of course, the most important thing is ocean heat content. These things are followed extremely well by NOAA, the US National Ocean and Atmospheric Administration. And we get monthly reports that we can check, and we get yearly. We're not going to be able to rely on that for very much longer, I'm afraid, because NOAA is going to be trashed and ended by, of course, the United States administration, which is the worst thing that's ever happened in the world, basically. So I do put out my concern, and thanks to all the scientists, I have known a couple of them that have already lost their jobs, and they're great people. So we've got to do all we can while we can with the data that we're getting. There are deep ocean heat waves, as well as the ocean heat waves at surface. They're not actually on the surface, actually, they're a fair bit below the surface. And in 2023, they were huge. They can map them, obviously. All the ocean basins had huge marine heat waves. And I suppose I should mention that ocean heating has doubled since 2005. The IPC says that marine heat waves have doubled since 1980 to 2016, and they're becoming more intense, longer, like land heat waves. But this is way actually more important than land heat waves because, as I say, this fundamentally controls the oceans, ultimately control the climate, and they ultimately control climate change and any ability that we have to mitigate climate change. So, with that depressing news, I'll say thank you.
Thanks, Peter. One of the, I think, insidious aspects of marine heat waves is, of course, the fact that they are out of sight and out of mind. They're occurring hundreds, if not thousands, of kilometers away from land in many cases, some cases much closer to land. And like all life in the ocean, it's mostly hidden from view. And the studies have shown that they are responsible for mass die-offs of ocean life. I coined a term, not one of the happier terms I coined in my book, biotic genocide. And that's basically what's happening. And we are doing it to them. This would not be happening without fossil fuel-based heating of the atmosphere that then goes into the oceans. We are directly contributing to the genocide, to the mass destruction and death of millions and perhaps billions of sea creatures of all sorts. And in fact, they're occurring so frequently that scientists recently have actually developed a numerical system to, identify them. Number six, number eight, they're not rare, they're not one-off anymore, as Peter has pointed out. So it's something that's terribly tragic, terribly critical for the life in the oceans, and of course, terribly critical for the climate and for all of us. And with that, I'm happy as always to introduce Paul Beckwith. Paul is a climate system scientist from Ottawa and is an inveterate and indefatigable YouTube producer of videos on every aspect of the climate crisis. Paul, the floor is yours.
Yes, thank you, Herb, and thank you, Peter. So the key thing about the ocean is that, the density of water is 1,000 times that of air. So the ocean acts as a buffer to try to stabilize the climate system. But unfortunately, over 90% of the heating on the planet is heating of the oceans. If we were to stop the forcing of the heating, the oceans, they're not in equilibrium with the air. They've absorbed so much heat that it would take time. There's a lag time of a few decades, perhaps 2 to 3 decades, where the heat will then come out of the ocean and heat the air. And there's all kinds of changes, physical, chemical, biological, that are occurring in the ocean, obviously, with it absorbing all this heat. So, first of all, it takes time for that heat to go to lower levels of the ocean. In order to do that, you need vertical mixing, which happens at many different locations on the planet, but this mixing, vertical mixing, is reducing. So we're getting ocean stratification. The surface waters are heating more. Obviously, they're the regions that are heating directly from the solar radiation increase and lack of cloud cover, which James Hansen's covered quite a bit. So therefore, the water on the surface of the oceans is warmer, it's less dense than the water below, so it tends to want to stay on the surface and not be brought to deeper depths. So the vertical mixing is reducing in the ocean. The vertical mixing is crucial for bringing oxygenated water from the surface down below to keep the living animals there able to, maintain their ecosystems or life in their ecosystem, because the oxygen is brought down. There's less of that happening, so that's really hurting life down below. And the vertical upwelling is very important to bring up the nutrients to the surface, where the nutrients are needed to allow the phytoplankton to proliferate, and they're the base of the food chain. So with less nutrients moving up to the surface, specifically phosphorus is a big problem, where it does really harm the ability of phytoplankton to multiply. So it cascades into the food, up the entire food web or marine web of life, if you like, and reduces the biodiversity, reduces the numbers of different species, the whole thing. So it's a big problem. In a limit, you can talk about things like can-filled oceans type situations where there's actually no or very little vertical mixing, and then you get you basically lose most of the life in the oceans from that type of situation, the Canfield Ocean. There's also acidification, which has been mentioned. The huge absorption of CO2 causes carbonic acid to form in the water, lowering the pH value. And this is harmful to marine life, but it also indicates that there's less CO2. The reduction of vertical mixing means that the CO2 is not being sequestered as quickly into the deep ocean. So therefore, the vast carbon sink of the oceans is reducing. And there's many papers that have come out in the last little while about this potential. Well, they're actually observing and measuring a reduction of the ocean sink, a reduction of CO2 going to deeper levels of the water and eventually to be sequestered on the ocean floor. So the carbon sink is failing. The AMOC, the Atlantic Meridional Overturning Circulation, is greatly reducing. This is having huge effects around the entire planet.
Thanks, Paul, for giving us that clarity with respect to some of the chemical and biochemical changes that are occurring in the ocean as a result of the heating up of the atmosphere, and of course the heating up of the oceans, which do absorb the overwhelming amount of heat, that the excess heat that is generated. And essentially the oceans have been our friend up until now in doing yeoman's like work in absorbing heat that would otherwise we would feel. But that is beginning, as you pointed out, Paul, beginning to change in very calamitous sort of ways. And let me turn it back to Peter for any additional thoughts you have.
Yeah, thank you, Herb. I've got a couple of things. There was a paper published February of this year, very recently, in Nature Climate Change, and really, really big, important paper. So I'll say what the title is. The title is Observed Multi-Decadal Increase in the Ocean's Surface Thermal Inertia. But this paper covers the ocean heat content as well as the rocketing sea surface temperature increase that we've got. And it mentioned and explained how this, of course, is very, very significant to increasing marine heat waves, which, by the way, are going to, no matter what happens, they're going to increase at a sort of multiplier rate, which is how the IPCC tracks them. These increases are absolutely enormous. But the paper also found that, quote, our study suggests that the ocean's ability to sequester heat is weakening. So of all the terrible, shocking news, and we've all had a lot of them, which we've had to ingest, this maybe is probably the worst. It's interesting to me that in James Lovelock's book, the late James Lovelock, was published in 2007. And he warned that we were really getting ourselves in one hell of a mess because of all the feedbacks that we were basically ignoring. And one of them was he said there'll come a time in the future when the heat will feed back. And the scientists all said, no, it's a very good book, but that's nonsense. So now we know that it can happen and that it already is happening. On that point, NOAA did a very good article last year in which they said heat already stored in the deeper layers of the ocean will eventually be released, committing the Earth to additional surface warming. So the terrible, terrible future of our planet, what the IPC calls an unlivable future, is what we are condemning, and not mainly our leaders and corporations, of course, are condemning the children, all the children in the world and all future generations too. I mean, this is an absolutely monumental, unimaginable evil that's going on. My final point is, of course, everything depends on phytoplankton. We all live because of phytoplankton. They are being impacted by, of course, these unprecedented SSTs, sea surface temperature increases. I learned today that they're also being affected by plastic, microplastic.
What you're pointing out, of course, and we've talked about this in various ways over the months and years, is how everything is connected. And we focus on one effect or one problem, and we don't realize until it's often too late that X affects Y, which affects Z. And so our scientists and thought leaders need to be having both a deep lens to look closely at these issues, but also a broad lens to look at the connections between them. And we try to do that in our short time with you every week. And you've certainly done that quite well, Peter, right now. Let me turn it back to Paul.
Yeah, so let's look at the basics of the Keeling curve, which is the famous measurement of CO2 from 1958 onwards at the top of the volcano Mauna Loa in Hawaii. And this curve it does have yearly fluctuation, a cyclical fluctuation, but it's basically going upwards at an accelerating rate. And from the some of the details of the curve, we can actually see what's happening. So we often fixate on greenhouse gas emissions from the fossil fuel industry. That's increasing. We less often look at the carbon sinks of the earth, the natural carbon sinks, and the ocean is by far the largest of those carbon sinks. And we've just said that with stratification and warming of the oceans, that carbon sink is reducing. So that's contributing to the upward rise of the greenhouse gases. And also, when the curve reaches a maximum level in a given year, the Keeling curve, it happens in sort of the late winter, early spring, and then the level starts to drop down. It dips down about 7 parts per million or something because of the growth of vegetation on the land in the northern hemisphere. And according to a recent paper, that particular sink peaked in about 2008, and now it's decreasing. So all of these factors are leading to higher and higher greenhouse gas levels, which of course leads to higher and higher warming, which then tends to reduce the sinks on both the land and in the ocean, meaning we get even higher levels. And this is like a runaway train. So I would be without any hope whatsoever that we can turn this thing around, except without the concept I often talk about, the three-legged bar stool. We need to slash fossil fuel emissions. We need to capture CO2 and methane from the atmosphere. But in order to do this, we need solar radiation management. We need to block some of the incoming sunlight to cool the planet so that we don't lose everything so that everything doesn't spiral out of control and we completely lose these sinks and we go to we rocket up to a much warmer world in a very short period of time. And I think we're seeing everything accelerating upwards, so we need to really work towards deploying some of these things to have any hope whatsoever of trying to stabilize the climate. We don't really have any choice on this matter, which is why I've been pushing this three-legged bar stool idea for many years.
Thanks, Paul. I want to emphasize as strongly as I can, the folks should go back and listen to what Paul just said if you didn't listen closely enough. It's something that the group I'm involved with, the Healthy Planet Action Coalition, also supports, that we need an urgent, emergency, coordinated effort that accelerates emission reductions, that begins to draw down massive quantities of CO2 and possibly other greenhouse gases if that's proved to be feasible. And most critically, and yes, most controversially, begins to put a sunshade or a sunscreen to limit the amount of sunlight by a very small amount that could have really miraculous impacts in stabilizing and ultimately lowering temperatures, giving the world the time to basically remove all of the excess greenhouse gases and stop emitting carbon dioxide, methane, and other greenhouse gases. It's a simple concept, and as Paul said, he's been promoting it for years. Some of us more recently are doing it, but it's still a tiny little corner of the climate world. We're trying our best, but we're just a handful of folks. Those of you who are intrigued with what you're hearing right now, we encourage you to go back through some of our earlier videos. We have one on the napkin diagram. Just Google the napkin diagram, and you'll see essentially a graphic representation of what Paul and I are talking about. To the degree to which people can open your eyes and your hearts to a three-part strategy, we think that is the only, at least I don't speak for all of us here, but certainly speak for myself and I think for Paul, that is really the only feasible way to avoid reaching unimaginable levels of calamity in the coming years and decades. So, with that little editorializing on my part, I want to thank, as always, Paul and Peter for your always on target and thoughtful and scientifically sophisticated comments. I just also want to say that, as you listen to this, in addition to focusing on the three-legged bar stool, or the triad, as I call it, I would urge you, particularly those in the United States, write to your congressional leaders and demand that they reinstate or not cut money for groups like NOAA, National Oceanic and Atmospheric Administration, which is literally, coincidentally, the headquarters is right around the corner from where I live, and I will be going to a demonstration there tomorrow morning, one of several that's occurred. There are many organizations that are working to preserve and restore the climate in the oceans. One that I particularly admire is called Ocean Visions. Go to Ocean Vision's website. They're actually having a big conference in Vancouver, I believe, later this month. So for those of you in Peter's neck of the woods, if you're available and able to go, I understand it'll be quite exciting with lots of new ideas for basically taking the bar stool and the triad and applying it to the ocean. So once again, if you found this program to be useful, please like it, subscribe to our channel. We have over 200 videos and more to come. Leave your comments and questions. Go to our website, climateemergencyforum.org, and we ask you to donate, even if it's the tiniest amount of money. Every little bit helps. Every little bit makes it more feasible for us to continue to bring you these very important programs from the Climate Emergency Forum. And we'll see you next week. Thanks so much for coming today.